Okay, this is a video explaining how to use the binomial coefficients, the binomial theorem, to answer questions which would otherwise be massively time consuming, but which can nonetheless be done using an extremely lengthy tree. So here's an example. The workforce of a large company is made up of males and females in the ratio 9 to 10. 1/3 of the male employees work part-time, and then 1/2 of the female employees work part-time. Now, we're now going to pick 8 employees. So the technical tree diagram for this is as follows. First, second, third, fourth, fifth, sixth, seventh, eighth. Male, female, male, female. You know, literally just going like this. And the summary will be the most enormous thing. It will be along that top path. It will be male, 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 male. And the probabilities of each of it will be 9/11, 9/11, 9/11, etc., etc. So the probability of this will be 9/11 times 9/11 times 9/11, etc. So 9/11 to the power of 8. Now, this one here, just underneath it, will be male, 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 female. So that will pick up 9/11 7 times, and then there'll be one last female there, which will be, oh wait on, it's not 9/11, it's 9/20. Sorry. And then times 11/20. That won't be the only one where that's the case. Wherever you go up a fork, you're picking up a male, and whenever you're going down a fork, you're picking up a female. So there's loads of other ways to get a single female. Here's another situation. That'll be somewhere in the summary of the tree. So male, female, so up, down, up, 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 up. Yeah, and so that'll be 9/20 times 11/20 times 9/20 to the power of 6, which is the same as that. So anyway, what's going on here is that I'm just thinking the tree, I'm getting my story straight. I'm now ready to answer the question. So, find the probability that all of them are females. Sorry, all of them are males. Well, that's it there. That's the answer to part 1. Now, find the probability that exactly 5 are females. So that's, for example, like going down, 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 and up, 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 up. So in other words, female, 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 male, 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 male. So you would pick up the female probability 3 times, and you would pick up the male probability 5 times. But as we established up here, that will not be the only time you see that. How many times will you see that? Well, it's really simple. Instead of counting or doing it really carefully, just use this button on the calculator. Up the top is how many repetitions there are in the tree, and then down the bottom is whatever you were actually asked about. Now I realise that I've misread this question. It says exactly 5 are females, so I should have, oh no, I've got that, yeah. So, however many you're interested in, the 5 females is what goes on the bottom, and then you just literally type that into a calculator. Now, question number 3, at least 2 work part-time. Now, up here, when I was building my tree, it was very straightforward to work out what the probability was that somebody was male and somebody was female. I just read it straight off this ratio. That's where I got my 9/20s and 11/20s for. The problem is I don't know what the chance is that somebody works part-time, so I'm just going to work it out. What's the probability a randomly selected person works part-time? Well, here we go. Stage 1, this is just a 2-fork tree. So, question 1 is male or female? Question 2 is part-time or not? So, what's the probability you're male? 9/20. What's the probability you're female? 11/20. What's the probability you work part-time if you're a man? 1/3. Therefore, not working part-time is 2/3. What's the probability you work part-time if you're female? 1/2. What's the probability you don't? 1/2. So my summary is male, yes to part-time. Male, no to part-time. Female, yes to part-time. Female, no to part-time. Multiply the probabilities to get what's on the branches. This is an annoying one because these are not all of a common denominator. The reason why that's annoying is because it's not so easy to check that up to 1, but that's okay. I'm just going to double all these and triple all these. They add up to 120, so that's good. Or rather, these fractions add up to 1. And so therefore, the probability that someone works part-time is this. It's 51 out of 120. Now, that is just the beginning of part 3. The whole reason I wanted to work that out is because in part 1 and 2, I knew these figures. Whereas for part 3, which is about working part-time or not, I didn't know those figures. I now do. So what I've got is a classic mega forking situation. It's still 8 employees. Now I recommend actually drawing these trees out just to get yourself in the groove. So the part-time status, if you always go up on the branch, is yes, 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 yes. So that would be, what did I work out it was? That would be 51/120 times by itself, loads, 8 repetitions. But if you want 2 working part-time, then you will go up twice and then down 6 times. So for example this, or this. Now if you're going down 6 times, you will pick up a probability of 69 out of 120. You'll pick that up 6 times. And going up, you'll pick it 51/120. You pick that up twice. And there'll be loads of repetitions. How many repetitions? It'll be this button on the calculator. And how many we wanted, the probability that 2 working part-times, you just put that there, type that into your calculator, and that's your answer.